In this short video, I just want to review the concepts first discussed back in Unit 1 and a little more extensively here in Unit 3 of apparent and absolute magnitude. These are two different ways of measuring the brightness or luminosity of an object. Apparent magnitude means exactly how it sounds. We're looking at how bright the star appears. How does it look to us here on Earth? The sun appears really bright to us, and the other stars in comparison look much less bright than the sun. But even when we look at stars in the night sky, some look brighter than others. This may or may not match up with how bright they really are. It all depends on how far away from us they are. This is where the other measure of brightness comes in. Absolute magnitude is basically a measure of how bright the star actually is, as if measured from a standard distance away. This distance is 10 parsecs, or almost 33 light years. Absolute magnitude is what we would see if we pushed the sun and all nearby stars back to 10 parsecs away and brought all the distant stars closer to 10 parsecs away. If everything was the same distance away, their brightness would look differently than it does now. Think of it like seeing a person coming toward you from way down the hall. At the end of the hall, that person might look tiny, maybe only an inch or two tall, but as they come forward towards you, they appear larger and larger. The same happens with stars. A star might look dim to us here on Earth because it's just a dim star. However, it might be an incredibly bright star that is just really far away. If we could bring that star closer to us, the closer and closer we bring it in, the brighter and brighter it looks. Let's look at some examples. I'm going to first draw a number line out to the side of this page. Remember that back in Unit 1, we talked briefly about star magnitude, and that bigger numbers actually mean the star is dimmer. Think of it like this. To see a big magnitude number star, you're going to need a big telescope. When we're talking about apparent magnitude, the object in our sky with the brightest appearance is the sun. The sun has an apparent magnitude of negative 26.7. Remember, the lower the number, the brighter the object. The full moon comes in next at negative 12.6. Venus has an apparent magnitude of negative 4.5. Sirius, the brightest star in our night sky, is slightly less bright than Venus at negative 1.5. Polaris, the North Star, is much dimmer, with an apparent magnitude of 2.0. The faintest stars we can see in our night sky are about magnitude 6. Now remember, all of this is what we see from here on Earth, but that's because all these objects are not only different in their inherent brightness, they are also at very different distances from Earth. So let's now compare this to absolute magnitude. Of all the objects we listed on the right, Polaris is actually much brighter than any of these other objects. The reason why it appears so dim to us on Earth is that it's actually 133 parsecs, or over 430 light years away. When we use absolute magnitude, remember that we're basically thinking of what we would see if this star was only 10 parsecs away, not 133. So if it was that much closer, it would be much brighter at a negative 3.6, almost as bright as Venus appears in our night sky now. Sirius, however, would actually appear dimmer at 1.42 on this scale. Sirius is between 2 and 3 parsecs away from Earth, so if we were to push it back to 10 parsecs away, it wouldn't look as bright. The Sun would also appear much dimmer at 10 parsecs away. The Sun is much closer than a parsec away, and if it were pushed back to 10 parsecs away, it would be quite faint, at only a 4.83. It would be one of the dimmer stars in the sky. Remember that we can only see stars with the naked eye to about magnitude 6. At 10 parsecs away, the Moon and Venus would not even be visible to us. They are too small and dim to be seen at that distance. Hopefully this helps to clear up the difference between these two ways to measure brightness.